Hello and welcome. So this is part of our Unit 4 polynomials. This is applications of the zero product property. So it's something that can be attached along with your 4.7 notes, or you can just keep this as a separate kind of informational piece. Pizzazz pages that go along with this are 105 and 106. Make sure you put your name and date on this, and we're going to go ahead and add some vocabulary pieces to this. Since we're working with applications, we're often working with word problems. So a couple of pieces to note. If we have a phrase that says 5 more than the square of a number, I'm going to write that as 5 plus x squared. And if I have something that looks like 9 less than 4 times the square of a number, I'm going to go ahead, let's go back a little ways there. That jumped ahead a little bit. I'm going to write x squared first and then subtract the 4. So if that's the case, it's important to recognize that I can flip-flop addition. So here we go, I'm going to flip-flop the addition up above and indicate that 5 plus x squared is the same as x squared plus 5. But when I take a look, x squared minus 4 is not the same as 4 minus x. That is not the case. So we want to be really careful, and the key item here is that less than, we have to change. Okay, we have to switch where we've got the order. So let's take a look at a couple of other vocab pieces that we're going to want to use. So consecutive integers. These are integers that go one after another, such as 6, 7, 8, or, I'm going to go back a ways, -3, -2, -1, and 0. Each time when we talk about consecutive integers, we're adding 1 from the previous integer. So we can look at that as though it's x and x plus 1. That's how we can go about taking a look at this. What happens if we talk about consecutive odd or even integers? You know, an odd integer might look like 1, 3, 5, 7, and an even integer could be like 2, 4, 6, 8. When we look at those, and here's a couple of examples again, each time, either it's even or odd, we're adding 2, no matter if it's even or odd. Because if I take a look here, even though that, I guess I shouldn't use the word even, nevertheless, I should use, if I'm working with -7, -5, and -3, each time I go from -7 to -5, I'm adding 2. And when I go from -5 to -3, I'm adding 2. So it doesn't really matter whether I'm working with an even number or an odd set of integers. Either time I've got x, and then I'm always going to add 2. If I wanted to go and take another one along with this, I could even have and add in x plus 4, because that would get me from the first integer of x to the second odd or even integer to then the third odd or even integer. So that's an important piece to work with. Okay, so now when I take a look at that, let's take a look at some key concepts, particularly applying to applications. And there's going to be some information on this method. So the first thing is to really read that problem carefully and identify the variables, which are the things that we don't know. That could be a length of a side, it could be, you know, in other word problems we've had, it could be an unknown number, it could be an unknown price, it could be an unknown amount of something. So perhaps we bought $3.50 worth of candy, and we wanted to know how many candy bars we purchased and all of that. So we can go through, and the unknown amount could be, the unknown could be an amount. Let's take a look at number 2. But before we do that, when we talk about reading the problem, sometimes it might be necessary to draw a picture. And when we're talking about area, absolutely, draw and sketch, label a picture if that's necessary. Next thing is to use the appropriate background information. So maybe when we talk about this, we're looking for a model to set up. So the background information could be talking about the area of a rectangle, such as the length times the width. And we're familiar, that's background information that we'd have. Another type of background information could be consecutive numbers, particularly consecutive integers. So x, x plus 1, x plus 2, etc. Now if we had consecutive odd or even, we'd have this change, and we wouldn't actually include this guy. That would be the one that would go away if we talked about odd or even integers. Let's take a look at step 3. Now we're going to apply the zero product property with this concept. So we've created a model. We're going to set up the zero product property, and again, in order to make that work, we need to set the equation equal to 0. Okay? It might, as area is never 0, you might have a model that you set up that's not equal to 0, but we can make it equal to 0. Then we're going to go ahead and factor and solve. Step 4 is going to be identifying the reasonable answers. If we're talking about area, we're going to knock off the negative numbers, because there really is no negative number when we talk about length or width or area. And finally, we're going to answer the original problem. If it asked us what the dimensions were, we need to give it both the length and the width. If it asked us for what the difference was between something, we need to answer the actual original question. So just finding x sometimes doesn't cut it. We have to do a little more. Let's take a look at our first kind of concept or answer here. And we're going to use a landscape project. So go ahead and add the section title, Applications for Zero Product Property. And we're going to shift gears into the other worksheet that's attached onto here. So what we did for part of class is we did have this situation where we were talking just specifically about the worksheet with area. And let's take a look at one of those problems and draw it in this so that we have it in our notes. Alright, so now I just moved this down so that I had some space. So just looking at the examples portion on the back side of this note sheet, we're going to take a look, and what if we were given the figure, and I'm going to draw this figure. It's a rectangle, so go ahead and draw the rectangle. And we're given information that the area of this rectangle is equal to 210 units squared. And we don't quite know what those units are, so we're just going to say UN for the abbreviation of units. We're told that the length is 2x plus 1, and the width is x. Now, given this information, we can go ahead and say, well, I know some stuff. And I was asked in there, so let's write down kind of the question itself. So we're going to write an equation to solve, to indicate how to find the length and the width of each rectangle. So we're going to write an equation. So let's have this question. And it tells us to write an equation. And we're going to write an equation, then solve to find the length and width of the rectangle. Say to solve the missing dimensions. Let's do that. And again, dimensions in this case are the length and the width. So maybe we should add that in just in case we're not quite sure what we mean by dimensions. So again, talking about that length and the width. Okay, and that's what it means for dimensions. So if that's my task, I'm going to go ahead and take a look, and I've got this concept for my length and my width. And I know that the model I'm going to use is this concept that area of a rectangle is the same thing as the length times the width. So I'm going to go ahead and do that. So I have this 210 units squared is equal to the length of 2x plus 1 times the width of x. Now to go about working on a solution for this, I need to solve, and I'm going to make this a bit smaller. So when I do that, I'm going to go ahead and sort of go along the process of simplifying. So in order to simplify, I'm going to distribute the x, and I get that 210 is equal to 2x squared plus x. Now this is where the zero product property comes in, and in order for me to use that zero product property as I was asked to in the method, I need to make this equal to 0. So in order to do that, I need to get this 210 onto the other side. And there are no other items. So when I take a look at this, I'm going to clear that up just a little bit so that looks like a 210. I do in fact get what I'm looking for at a 0 is equal to 2x squared plus x minus 210. Now I get to go ahead and factor this guy. And let me tell you, this might take a little bit of time, but it's definitely worth it. So when I factor this, I notice that there is not a greatest common factor, and there are 3 terms. And the first term, coefficient, is not 1. So that tells me I need to use reverse FOIL. Now going ahead and doing that, let's multiply the 2 and the negative 210, and I've got a pretty big number there. I'm still going to be able to manage this, but it might take a minute, and that's okay. Sometimes math just takes a minute. So we're going to have this idea of negative 420, and we're going to go ahead and try and factor. And when I do this, I could go all through that huge amount and go 1 and 420, 2 and 210. I know I want to find something that will get me kind of close to 1. So I need these numbers, these factors pairs. I'm looking for one that's going to add to 1. So I'm going to have a fairly big number. So I'm going to take a look and see what I find. So like I said, rather than going 1 and 420 and then 2 and 210, I can go about this process a little bit faster by saying, let's guess and check kind of larger numbers. So I know that it has a 0 there, so why don't I just check out 10? So if I had 10, I would have 42. And those aren't close to each other. But I'm going to go by the next factor of 10 and take a look at 20. And when I divide 420 by 20, I end up getting the answer of 21. And these guys, if I was to subtract them, would in fact give me that 1. And in order for it to be a positive 1, I want the smaller number to be negative. So I'm going to go ahead and pop in some negative signs for these guys here. And lo and behold, that's the one that I want to use. So in doing this, I'm going to use my factor box and organize that now. So this would look like this. So we're going to do a quick box. Inside I'm going to write the first term, which is 2x squared. I'm going to make this a little bigger so I can get pretty small in there. I'm going to write in negative 20x and a positive 21x because of my factor pair I chose. And then I'm going to write in that negative 210. Using my calculator always to help me out if I need, I can absolutely do that. Finding the GCF of each row and column is where I'm headed next. So I'm going to indicate that in the first row I can take a 2x out of both. In the bottom row it looks like I can take a 21 out of both. In the first column here, it appears that I can take just an x. And in this second column here, it looks like I can take a negative 10 out. Making sure that I check my work, I'm going to double check that x times x in fact gives me 2x squared. 2x times negative 10 in fact gives me negative 20x. X times 21 works out. And 21 times negative 10 also checks. So that's a really good sign. And we're going to indicate the information that we just found. So when we factor, we're going to go ahead and write in our factor binomials. Again, working through those being equal to 0. So I have this concept of x minus 10 and 2x plus 21. I'm going to set each one of these equal to 0 as that is the zero product property. And that allows me to solve. So this would then give x minus 10 equal to 0 and 2x plus 21 equal to 0. Here I can add 10 to both sides and I get a value of 10 as a positive. That's a really good sign. And then I can go ahead and take a look at this and say negative 21 on both sides, get 2x is equal to negative 21, and find that it's fractional, which is okay. And I'll find that when I divide by 2, I get x is equal to, and let's maybe leave it as the improper fraction. Or we could also look at that and say it's the same as 10.5, so negative 10.5. When I cut that in half. So those are my two options. So the next thing I want to do is, hey, I've used the zero product property. I've found the solutions. Which ones are reasonable? And this is where we're talking about the information being really important. And if we can take a look, I'm actually going to try and shrink this up a little bit and move it so that we can really see. If I have that concept and I'm like, whoa, how do I know which one is like the right one? I don't know. Reasonable, just take a look. What is it asking? In this problem, we're talking about area. So is it reasonable to have a fraction? Yes. However, is it reasonable to have a negative number? No. So it's important to recognize that I'm going to x-nay this problem right here. The solution of negative 1/2, and I'm actually going to get rid of it. I'm going to maybe put it in orange to be like, woo, 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 woo. This guy right here is not one that we want to use. And it's not one that we want to use, again, in part, because it's that negative. It has nothing to do with the fact that it's a fraction. I do, however, want to use the value in solution that I found to be 10. So if I go ahead and plug in this concept of x equal to 10, that means that this is equal to 10. And that means that this is equal to 2 times 10 plus 1. Or in fact 20 plus 1, or 21. So maybe let's just write down 21. So that's a really nice kind of unique piece. I'm going to write a sentence indicating what my answer is. So I can always check that to say 10 times 21, does it in fact equal 210 units squared? And in fact it does. So in kind of a blank space, I'm going to write down the dimensions. So the dimensions, actually I'm just going to say the length is 21 units, and the width is 10 units. Excellent. So that is kind of that last piece of making sure that I answer the problem. If this by any chance asked me what the perimeter was, I'd go ahead and add up all the sides. So I would add the 10. Whoa, let's go back. I'd go ahead and add up all of the sides for that, so now that we're back in this page. So that would be if I maybe was asked not just the dimensions, but to find the perimeter when I knew the area was 210. So some indications here of information that we can use and continue to work on. So in class, we have this concept over here. We're going to be taking a look at this quadratic model using landscape design. And this is a really unique idea. It says, if you are putting a stone border along two sides of a rectangular Japanese garden that measures 6 yards by 15 yards, your budget limits you to only enough stone to cover 46 yards squared. So you have this beautiful picture diagram for you. We want to know how wide the border should be. So we are not sure of that length and that length. Since it's going to be the same because it's a border, we can make sure that we indicate that to be X along there and there. And we were given this information to be 15 and this information here to be 6. Because we know the actual dimensions of the Japanese garden, we don't know what the new dimensions would be once we put the stone border in. So we've gone ahead and labeled the diagram with the length and the width and the pieces that we don't know. So we're going to use the concept below to set up the problem of area of the border is equal to the total area times or minus the area of the garden. So we know that area. So we're going to kind of tackle this problem when we get into class. It's important for us to take a look at this. If you would be so kind, it's important I'd like you to tackle, so in pencil, please write, so try this on your own. I'd like you to try and create this concept of the area of the border, which is something that we don't know, but we know how much. So we're going to use this concept of the area of the border being 46 square yards, and having that equal the total area, which is going to be length times width, so we would be multiplying that by that times that for the total area, and then we'd subtract the garden width and length for the area, so we'd multiply 6 times 15, so hopefully I believe we would be subtracting 90. So go ahead, try and set that up on your own. maybe take a couple of steps. I'd like you to try and set it equal to 0 here. You don't have to go through the entire problem of solving it, but I would like to see some attempt here on this particular problem. And we'll go ahead and fix that when we get in class. Thanks for your time. See you next